So let's start. Okay. So yesterday we're discussing central tendency concepts. Okay. So we're discussing central tendency concepts like mean, okay, and median and mode, okay, and range. Fine. So just to give a recap, mean will get influenced, okay, by any outliers. So that's why it's not the most robust central tendency measure. But median more or less stays at the same place. Okay. Mode, coming to mode, what we have seen, a set of sequence of numbers can have no mode, one mode, or multiple modes. Range is just the largest number minus the smallest number. Okay, fine. So these are few examples, I would say. So now let's actually look at some code. Okay, so measures of central tendencies, and let's say we are having this data set. Okay, we are having this data set and we are going to import it. Okay, so we did not come to these yet, numpy pandas. Okay, after this module we are going to study this, but as of now just understand that numpy is numerical python, okay, which will help us to do some numerical calculations, okay, like addition, subtraction, medians, means, standard deviations, variance, etc. Okay, pandas is mostly used to access and play with the data frames or the tables or excel files. Okay, so we are, as you can see, we are reading the file using pd, pandas pd, right, pd.read csv, and there is one file called as auto csv. Okay, now this is my file. Now if you see, okay, let me come on this file. Now fine. So my empty cars, okay, my empty cars is my data set. Okay. Over here, if I do mean, okay, so yesterday we have studied mean, right? So now if I try to, if I want to find out the mean of the given data frame, you can simply say empty cars, which is my data frame dot mean, okay, which will give you the mean of every single column. Okay, as you can see, mpg, the whole data frame, sorry, whole column, okay, the whole column mean is 23.51. Fine, the whole column cylinder mean is 5.5. Okay, so here it is having like not only 5 rows, but if you see, to know the, you can say empty guard. So it's having total 9 columns and 398 rows. Okay, so the 398 values of mpg, if you do sum and divide by 398, okay, you will get the mean. Okay, so to find out the mean, you can simply do empty cars dot mean. Okay, to give each and every column mean, get each and mean of each column. Okay, but if you want to find out mean of each row, okay, that means each row is representing what? Each row is representing a car. Okay, this first row is the details of Chevrolet vehicle. Second row is the details of some Skylar car. Okay, so if you want to find out the mean of all the parameters of this car, that means you should do, if you want to get the mean of all the values in a row. Okay, in that case you can just say access equal to 1. Okay, so same empty cars dot mean, fine, empty cars dot mean, access equal to 1 will give you the mean of each and every row. Okay, only mean will give you the column wise operation, access equal to 1 will give you the row wise of operation. Fine, so now if you see, the median of a distribution is a value where 50% of the data lies in it and 50% of the data lies above it. Okay, so yeah, so this point what we are reading here is very important actually. So you are going to see its importance in next class when we are discussing something called as percentile. You're going to understand it. But now what we are saying, yesterday we have seen mean, median, mode. Okay, We have seen mean, median, mode. In that median, what did we study about median? It is the middle number, right? It is the middle number. Agree? So when I say it's a middle number, that means what? 50% of the data, 50% of the data should be below it, and 50% of the data should be above it. Agree? Only then we can call this as a middle number, right? So in essence, the median splits the data into half. Okay. So now to find out the median of the given number, given column. So you can simply say same empty cars the data frame dot median. Okay, you can call this function. So it gives the median of each and every column. Okay, so for example, if you see, okay, so you have something called as 23 in the first column, and that is a median. That means what? That means 50% of the values, okay, out of total values, 50% of them will be less than 23. Okay, whatever the values you are having, and remaining 50% of them will be greater than 23. Okay, so out of this 398 values, okay, 398 values, let's say 400, right? Approximately 200 values will be less than 23, and remaining values will be greater than 23. Okay, so that is the concept. Yeah, as you can see, okay, as you can see, if I just copy that column, okay, and just if I sort the values, okay, you remember, right? For median, first thing you need to do is what? You need to sort. Okay, I hope you remember. So for median, you need to sort, because when you are taking the middle number, obviously the order is important. Okay, if you change the order, the middle number will change. So for the median, you should first sort, okay, and then go for the median. Okay, so now as you can clearly see, this is a given column, but if I take the column and just sort it, and as I have shown here, what was it is saying the median is 23. That means what? The middle number is 23. That means what? Out of, let's say, if you roughly consider 400, that means 200. At 200 you should have the median. That means 200 values will be below 23, and 200 values will be above 23, total 400. Okay, so that's why you can clearly see, if I go to around 200, yeah, see, around 199, 200, you are having 23. Clear? So that means above this you will have like 50% of the values, and below this you will have another 50% of the values. Okay, so that is a median. Fine. And same thing, if you can see here again, we could get the median. Yeah, for each and every row, if you want to do, you can go and find the what? Each row median. Okay, fine. So now, although mean and median both give a same sense of the center of the distribution, then they are not always the same. Okay, the median always gives us a value that splits the data into two halves, while the mean is a numeric average. So extreme values can have significant impact on the mean. Clear? See, it is clearly saying that even though mean and median, okay, they are trying to give us the same meaning, okay, they are actually different, right? Mean is just telling you, mean is saying, hey, I am that number x, where 50, I will divide the data into 50, 50. I will divide it into two halves. Okay, I'll just divide the data into two halves. Okay, that is my goal. But mean goal is what? Mean goal is just the average. It's a numeric average. Okay, so that's why as we have seen yesterday, any new number that is getting added to the data set, mean will think it's its responsibility to do justice to this number also, and it will try to shift in that direction, so it gets easily influenced. Yesterday we have seen, so today we can see that practically. So as you can see, the mean will always gives us a value that splits the data into two halves, while the mean is numeric average. So this line is important. So the significant values can have a, sorry, the extreme values. That means, let's say outliers or very large values when compared to the remaining values in the given data set can have a significant impact on the mean. Okay. So in a symmetric distribution, the mean and median will be same. Okay. We are going to see this line in very detail, but let's see some example about the mean and median. Okay. Just give me a second, guys. Okay, fine. So now if you see, let's try to create a distribution and let's try to see uh, the mean and median. Okay, so now we are trying to just create a distribution. Okay, so we are going to see in stats, we are going to see many types of distributions. Okay, we are going to see many types of probability distributions, sorry, probability distribution functions, and then we are going to see some normal distributions, okay, and non-normal distributions. Many distributions we are going to see actually. Okay, just giving a heads up. But now this is only for the mean median part. Okay, now here what I'm trying to do, see here I am trying to create a data. Okay, pd dot data frame will create the data frame. What is pd? Pd is pandas. We have imported as pd dot data frame, and I'm trying to collect the data frame. That means a table of values where how I'm trying to create, I will trying to create with the 1 lakh data points, such that those will be these points will be in the normal form. Okay, np dot random dot normal will create it into the normal form. This word normal, what we are seeing here, is one of the extremely important word in the whole statistics for the data science. Okay, this is going to change many things going forward. Okay, so but now I'll just give you an example what does normal mean. Okay, so see guys, to study this, okay, to study this we need to just switch to some other concepts and we will come back here. Okay, we need to switch to something called as skewness effects and use of central tendencies. Okay, see, there are two concepts. Fine, so we need to study few things over here. Okay, see, as I said, we are entering into core stats. Like these concepts are going to be very helpful and useful. Fine. So first thing is you need to know about few terms. One is symmetric. Okay, symmetric distribution. Okay, and second thing will be asymmetric. Okay, distribution. Fine. Symmetric distribution, asymmetric distribution. Now what does a symmetric distribution mean is simple. So if at all you are having any distribution, okay, if at all you are having any distribution, okay, where okay, where left side portion where left side portion is same as the right side portion. Okay, where left side portion is same as the right side portion, that is called a symmetric distribution. Okay, if left side portion is not equal to right side portion, okay, that is asymmetric distribution. Okay, see, if you see here, if at all you, if this is the mean, okay, let's say this is the mean, the average value. Here the left side portion is same as the right side portion. Okay, that is symmetric. Fine. But in the asymmetric, the both sides will be different from each other. Okay. Now from this symmetric and asymmetric distribution, you have something called as normal distribution. Okay, we have something called as normal distribution. Normal distribution is, okay, so I'm just give you just like introduction to normal distribution, but in next class we are going to completely discuss and go deep into normal distribution. Okay, because normal distribution or also called as Gaussian distribution is the most important concept which anyone who is studying statistics should know. Okay, but as of now understand normal distribution is a symmetric distribution where the shape will be like a bell curve. Okay, it should be bell curve. Okay, and this is normal distribution. Okay, now 2 3 important points over here. First thing is symmetric distribution is simply the distribution where you have left side portion equal to right side portion. Now asymmetric is left side not equal to right side. Normal is left side equal to right side. Obviously, that means this is symmetric distribution, but the shape should be in the form of a bell curve distribution. But for symmetric distribution, if you're talking only about symmetric, that means only left side and should be equal to right side. That is fine. And that shape could be anything. Okay, that shape could be anything. If you're having some distribution, okay, I'm having this distribution. Okay, this is also symmetric, guys, because left side equal to right side, it is symmetric. Okay, if I have some distribution, okay, I don't know, see some distribution, this is also symmetric. Okay, if left side equal to right side, just understand that is symmetric. Okay, the mirror images of each other are same, then it is symmetric. If they're not same, then they're asymmetric. Okay, but coming to symmetric, normal distribution now can be called as a special case of symmetric distribution where left side equal to right side, that means both of them are mirror images to each other, but along with that the shape should be in the bell curve. Okay, the shape should be in the bell curve. Okay, getting us, is this clear? Okay, so now if you try to see, can you tell me if is my statement correct? Can I say all normal distributions are symmetric distributions, but all symmetric distributions are not normal distributions? If I try to make this statement, is this correct, guys? Can I say this? All, hmm?
Yes, sir.
I can say, right? So, but can I say all symmetric distributions are normal distributions? Can I say all symmetric distributions are normal distributions?
No.
Correct. Right. So symmetric distribution could be any distribution where the only requirement is it should be mirror image of each other. But normal distribution is a special case of symmetric distribution wherein it should definitely be in the shape of a bell curve. Okay. So that is the difference you should be able to understand. But coming to asymmetric, the normal the left side will not be equal to right side. That means both of them will not be mirror image of each other. Okay, so remember these words. Okay, as I said, you will be coming across different words. So symmetric distribution, asymmetric distribution, and inside symmetric you have something called as normal distribution. Okay, fine. Now coming to asymmetric distribution, what is happening here? If you're having it is not like normal. This is normal, right? Now it is not having normal. That means what? So it might be some like this. Okay, it might be like this, or it might be like this. Okay, if you take it into half, okay, from mean or median, if you try to divide it, okay, so the right side will not be equal to left side. Okay, so as you can understand why this can happen. Okay, why this can happen? Because due to outliers. Okay, due to outliers it can happen, because in yesterday's example, as we have seen, if you're having 1 2 3, suddenly if you see a number called as 100, so obviously this 100 is disturbing the pattern over here, right? The graph shape changes. Okay, so due to these reasons you can have these differences. Okay, so we will see that. Okay, and we'll come back. See, skewness, you have something called as skewness. So we have seen central tendencies, right? We have seen central tendencies like mean, median, fine. In a symmetric distribution. Okay, so now I will try to take one point and I will come back. Okay, so here if you see, in a symmetric distribution, the mean and the median will be the same. Okay, the mean and median will be same. Fine. So that means what? If you have 1 2 3 4 5, okay, if you have 1 2 3 4 5, fine. So what's happening over here? If you, what is the mean? Mean is 9 10 13 15 by 3. So 15 by 5, 3. Median is also 3. Okay, median is also 3. Fine. But if I add 100, if I add 100, mean is changing to some 16, median is going to be 3. Fine. So when I'm adding 100, it is asymmetric. It becomes asymmetric. Okay. But with 1 2 3 4 5, this is a symmetric distribution. Fine. In symmetric distribution, the mean and median will be same. They will be overlapping or coinciding with each other. But with with asymmetric distribution, those will be different from each other. Okay, we will see an example so that you will have a better understanding. Okay, so now coming back, before that, let's try to understand skewness. Okay, skewness is asymmetry in a statistical distribution. Okay, simply skewness means there is some asymmetry. That means what? It is not a symmetric distribution. Fine. So we have seen asymmetric, right, where left side is not equal to right side. So that means in those distributions there is some degree of skewness. That means there is some di disturbance. Okay, in simple words, it is not symmetric. That means what's happening, there is some degree of distortion, or there is some shape out sort of thing. Okay, so in simple words, technically you can call them, there is some degree of asymmetry that is included in the distribution. Okay, in which, okay, in skewness, that means in asymmetric distribution, the curve appears distorted or skewed either to the left or the right. Okay, that means, as you can see, either to the left or the right means, if at all, if you're having a normal distribution, okay, a normal distribution is looks like this. Okay, but an asymmetric distribution, as it is mentioned over here, the curve appears distorted or skewed either to the right or left. Okay, that means either it will get skewed over here, or it might get like this. Okay, so this is getting moved away, or this is getting shifted from normal distribution, right? So this is getting shifted from symmetric distribution, because now this is asymmetric. Okay, now skewness is a measure like how far, okay, to how much extent a distribution is differing from a normal distribution. Okay, so how much is different, because in skewness also there could be multiple skewness, right? So if at all you're having a bit distortion, that is a small skewness is happening. Okay, if you have a lot of skewness, okay, or if you're having something unusual degree of skewness, right? So there could be different types of asymmetric distribution. Any distribution, as I said, if it is not following the mirror image concept. That means if the left side is not equal to right side portion, obviously it is asymmetric. Fine. So in a normal distribution, the graph appears as classical symmetrical bell-shaped curve. The mean or the average and the mode or maximum point of the curve are equal. Okay, this is extremely important point which you are seeing. Normal distribution, the graph appears to be classical symmetrical bell-shaped curve. Okay, it is bell-shaped and also it is symmetrical. Okay, in the distributions, the mean, the average, and the mode, okay, or the maximum point, everything will be the same. So all of them will be over here. Okay, so in these distributions you will have the mean. This will be the mean, the middle point, and this will also be the median. See why mean? Because for all these points the middle point, so not the middle point, the average point will be this. And why it is median? The median is because this, only this point, as you can see, is dividing the data into two halves. Why? Because if you remember, median is what? It is just that point which will divide the given data set into two halves, 50-50. We have seen an example, right? 50-50. So you can clearly see this is the point where the given data shape can be divided into 50, 50, 50. Okay. Now if you see, in a perfect normal distribution, okay, in a perfect normal distribution, the tails on the either side of the curve are exact mirror image of each other. Okay, we have seen. When a distribution is skewed to the left, the tail of the curve's left hand is longer than the tail on the right side, and the mean is less than the mode. The situation is called negative skewness. Okay, we will see. And the skew is distributed to right. The tail on the right side is longer than the tail on the left side. The mean is greater than the mode. The situation is called positive skewness. Okay, so now let's see. Observe here, this is important. Okay, so here if you see, this is symmetrical distribution, guys. Okay, and that means this is also normal distribution. Okay, this is also a normal distribution, but since we are not entering into normal distributions, we are just confining to symmetric distribution. Okay, fine. Here in symmetric distributions, you are having the mean, median, and mode at the center. Okay, mean, median, and mode at the center. All of them will be at the same point. Okay. Now, if you see a positive, as we have seen, skewness concept is related to asymmetric. Okay, if it is asymmetric, that means it is having some skewness, right? So, as I was seen, you can have two types of skews: positive skew, negative skew. Okay, see here, you actually the curve should be like this. Actually, the curve should be like this. But if the right side is longer, okay, the left side is same. As you can see, left side is okay. If at all this comes, and if this happens, okay, if this happens, then this is a normal. But that is not happening. Okay, it is getting elongated. Okay, so that's why if the right side portion is getting extended, okay, then it is called positive skew. Okay, if the left side portion is getting extended, it's called negative skew. Okay, and here one very important and funny thing is happening. If you see, yesterday, if you remember, guys, yesterday what's happening? 1, 2, 3, 4, 5. Mean is what? Mean is 3. Okay, mean is 3. If I had 100, okay, so mean is here. If I add 100, what is the mean? 16. That means what? Mean is jumping from here to here, some 16. Okay, like a Tom and Jerry, it is jumping from here to here. If I add minus 100, the mean will jump here. Agree? What is the mean? Nature of mean is to do justice to every new member, right? So we have discussed it yesterday and today also. So it gets easily disturbed and influenced by any new numbers. Agree? So if you add any number over here, it will shift from here to here. If you add again, let's say 5,000, it will again shift from here. Okay. So mean will constantly try to change as per the new values. So in other words, if at all you are having any outliers, okay, if at all you are having any outliers, mean is the one which will get easily disturbed. So here if you can see here, in a normal distribution, there are no outliers. Okay, here, what is an outlier? Okay, don't get confused by the word outlier. That means unwanted number. As of now, you can see unwanted number. Okay, what all the words which we are using? Okay, like normal distribution, outlier, percentile. Okay, we are going to see in full depths. Okay, in future classes, but initially let's try to get familiar with these words. Okay, so outlier is just, as of now you can understand, outlier is just an unwanted number, or the number which does not looks like that is fitting into the given pattern. Okay, as you can see, 1 2 3 4 5, clearly 100 with the outlier. Because of this 100, there will be having some degree of disturbance or skewness. Okay, but if you have only 1 2 3 4 5, then it will be a perfect what is this will be a perfect normal distribution. Okay, here there will not be any disturbances in the shape of the curve. Okay, but let's say if you're having 100. Okay, so because of this 100, as an example, the curve gets shifted. Okay, the curve gets shifted like this. If you have minus 100, for example, the curve gets shifted like this. Okay, the curve gets shifted like this. Now if you see here, funnily, initially mean is like this. Now when I say 100, it is shifting to 16. So as you can see here clearly, mean, median, mode are here in positive skew. That means if you're adding 100, mean or median, almost both are saying same. So median, there is a small shift in the median, but majority of the shift is happening for the mean. Okay, from here, from this point, okay, it has shifted to this point. Agree? The dotted line is now the mean. Okay, the dotted line is the mean. Okay, agree? Median, a small shift is there because one number it will shift. Okay, earlier if there are like 1 2 3 4 5 5 numbers, now there are 6 numbers, right? First 6 numbers, what it will do, so what we need to do, we need to take the sort them and take the middle two numbers and take the average of it. Okay, 7 by 2, 3.5. 3.5 will be the median. If you add 100, okay, let's say this minus 100 is not there. So if you add 100, so it's 3.5. That means from 3 to 3.5 it will just shift. Okay, from 3 to 3.5, the small shift. But what is mean is shifting? Mean is shifting to 16. Okay, 16, from 5 to 16 is shifting. So as you can see, this shift is there, right? That is clearly you can see mean is getting shifted. Okay, that is a positive skewness. Similarly, if you add some numbers to the other end, okay, so to balance that, mean will now shift here. As you can see, mean is shifting from this area to this. Okay, in the negative side. So now here what's happening in a, now we can make a clear statement that in a normal distribution, mean and median and mode will be same, but in a positive skew, mean will be greater than what? Mode or median. Okay, what is mode, guys? Mode is the maximum number which is appearing, right? So that's why mode will, wherever you this the highest point, right, wherever you see this highest point, right, so that will be the mode always. Okay, wherever see this is a peak point. Okay, the maximum number. Okay, that is the mode. Fine. So now in a positive skew, mean is shifting away from the mode. Mean is shifting away from the mode, and it will be greater than the mode. Okay, so that means what? If you have the number line, if you have a 0 1 2 3 4 5 6, something like that, initially everybody are at the 3. Okay, initially everybody are at the 3, but in a positive skew, mean is shifting away from mode, but shifting in which direction? In this direction. Okay, that means now mean will be, the value of mean is 4. Okay, the mean will be greater than the mode. Okay, but in the negative skew, mean mode for this, here you have 3. Okay, so it is going back. Okay, it is coming this side, negative, left side. That means what it will be? Let's say 2. Okay, 2 will be the mean. Now it will be less than the mode. Okay, here it will be equal to mode, here it will be greater than the mode, and here it will be less than the mode. Okay, as you can clearly see the shiftings because of the skewness. Okay, yeah, any doubts, guys? Is this clear? Are you
Sir,
getting?
clear.
Okay. Now, if you see, that's why here it is mentioned that in a distribution is skewed to left. That means this left. Okay. The mean will be less than the mode. Okay. So if I just pull it down a bit, yeah. So in a distribution skewed to the left distribution, okay, the left hand will be longer. Okay, so try to just memorize this, the skew negative and positive. That means positive will be right side will be longer, and negative will be left side will be longer. Okay, left side direction will be longer. When I say left skewed, that means left side will be longer. If I say right skewed, right side will be longer. And when I say left skewed, it will be negative, right skewed will be positive. Okay, as you can see, left side skewed, the mean is less than the mode. That means mean is shifting this direction, the mode is staying over there only. But coming to the right side skewed, the right side will be longer. Okay, and the tail of the left hand side will be the same. Okay, and the mean is greater than the mode. Okay, this is called the positive skewness. Okay, so now, okay, so now what are the new terms we have studied? We studied symmetric. In that we have seen normal distribution, fine. And then we have studied asymmetric, fine. In that we have seen something called as skewness, fine. And in this we have seen what? Positive skew and negative skew. And in between, if the skewness is zero, you will have symmetric distribution. Okay, so as that's why in the initial point we have seen something called as skewness is just the degree of, okay, it's just, if you call degree of asymmetricness, degree of asymmetricness. Agree, guys? That means what? Let's say it is a measure how much asymmetric it is. That means how much it is deviating from normal distribution. So if my skewness is equal to 10, that means 10% of it is asymmetric. Okay, that means it might be slightly something like this. Okay, if it is 50, that means 50% of it is, it's very asymmetric. Okay, but if skewness is zero, that means skewness is zero is means what? There is no skewness. There is no skewness means what? It is completely symmetric. Okay, so that's why here we have seen the skewness parameter will be in the middle. Okay, so if it is less than, if it is like negative skew, positive skewness, you will have positive skewness. If it is having negative skewness, you will have negative skewness. Okay, negative asymmetric distribution. But if the skewness is equal to zero, then there is no asymmetricness. It will be perfectly symmetric distribution, or as an example, normal distribution. Okay, fine. So I hope these concepts are understood by you. Okay, so now we'll try to see some example. Okay, fine. So if at all, yeah, we first will see the practical example over here and we'll come back. Okay, so now if you see, okay, so now if you see, now since we understood the reason why I went there is, here we have this word called as in symmetric distribution, the mean, median, and the will be same, right? So we'll try to understand. So now, since you understood what is symmetric distribution, okay, since what you understood symmetric, you will be better positioned to understand this. Fine. So now, as you can see here, and also, yeah, and also for this word we went over there. Okay, this normal distribution which we have seen. Okay, that means what? Now you understood, right? What is normal? Normal is a symmetric distribution. Okay, now to create this normal distribution, you can just say pandas dot data frame. I want to create a data frame wherein I want to take some points. How many points? 1 lakh points I want to take. And what type of points I want to take? I don't want to take any random points. I want to take those points which fall in some normal shape. Okay, all these 1 lakh points I want to put them in the normal distribution form and just want to create those data points. Okay, so this is how you can just create a normal distribution data, and after that you can just plot the data. Okay, so using the plot dot plot, you can just see. Okay, so dot plot will come from matplotlib. Okay, so as you can see, matplotlib. Okay, so these three things you are going to see in detail after the stats module. That means numpy, numerical calculations, pandas, data frame, accessing and playing, matplotlib, different types of visualizations. Okay, along with that there is also another visualization module called as Seaborn. Okay, so don't worry. So these four, once stats is done, right, we are going to see. The reason is these what are the things you are going to study here. So you will see a direct application in the ML module, because after stats we are going to see this, and after that we are going to see ML, right? So I want to put these and ML side by side, because if I complete this and then if I put stats in middle, and by the time I go here, you might forget this. Okay, so that's why let's complete stats, and then these are small concepts but very very important concepts. Post this, we'll go here. Okay, so but as of now, just understand, plot is coming from this matplotlib.pyplot. Okay, so it is just useful to plot some data. Okay, so now as you can see, in single line you are using all the three, using numpy. Np.np is numpy, pd is pandas. Okay, using numpy you are taking the data, okay, in the normal form, and that you are creating a data frame table sort of structure with the pandas, and with plot, that means matplotlib, you are plotting the data. Okay, so figure is just figure size, and density is like the shape, how you want. Okay, the a dark line shape. Okay, and 10 by 10 is a figure size. Okay, so now normal data you have plotted, that is your normal data plotting. And what with that, you are plotting two things. We are plotting mean also, median also. How you are getting mean? See, this is the normal data, and normal data dot mean will give you the mean. Simply we have seen right, empty cars dot mean give us the mean, simple. And empty cars dot median give us the median, right? Similarly, for single data, if you do the dot median, you will get the mean. If you do dot mean, median dot median, median. And this is how you are plotting. And plot plt dot v lines. Okay, v lines is for vertical lines. Okay, vertical line, you want to draw a vertical line at where, at the black sorry, at uh, normal data dot mean. Okay, wherever the normal data mean is calculated, right, at that particular position you want to draw a vertical line. Okay, so these are just the minimum and maximum values, how much the length the line should be. Okay, and the line width. Okay, these are the basic parameters. Okay, but the main thing is you are drawing a vertical line, v line, at what position? At the mean position. Similarly, you want to draw another vertical line at median position. Okay, normal data dot median you want to draw. Fine. So by default the color will be black, guys. Okay, that's why if you don't mention any color over here, it will take black color. But if you want to change the color, you can say color equal to red. Okay, for median you are taking the red color, and for the mean you are taking the default black color. Okay, now if I run this, okay, you will get something like this. Okay, as you can see, as you can clearly see, this is a symmetric distribution. Okay, so can you say, is this symmetric distribution, or is this normal distribution, or is this symmetric plus normal distribution? Can someone say? Sirisha, what I'm asking, what you are asking, the code is in R on Python. This is Python. Yeah, so can nobody can't you say what type, whatever distribution is this we have just seen? Is this symmetric or normal, or symmetric and normal?
Symmetric and normal.
Symmetric and normal. Okay, but not exactly, not strictly normal, Meghana, but that's fine, you can call as of now with the concept which you are studying. But normal is normal will be actually it's like the bell curve. Okay, but that's fine, you as of now you can say, okay, this is actually a better example of a symmetric distribution. Okay, fine. So now with this distribution, but our scope, our point is to have a symmetric distribution. Okay, because why? We have clearly seen over here. Okay, we have clearly seen over here, for a symmetric distribution, the mean and median or mode will be the same. Okay, that's we are trying to prove here. So practically, we have taken an example of normal means what? Symmetric distribution. Okay, and now we are having. Okay, now we are having what? As you can see, black. Can you see the black line below? That is mean. Okay, can you see the red line over here? That is median. Okay, and as you can see, the mean and median are at the exactly the same position. Getting? And what? So it has created values, okay, ranging from minus 7.5, okay, minus 7.5 to plus 7.5 it has created. Okay, guys, see guys, and total how many points it has created? 1 lakh points with use of 1 lakh points. Okay, that means what? Each and every place you will have 1 point. Okay, so like that 1.1 lakh points it has created. And there if you see at zero position, at zero, because minus 7.5 plus 7.5, what will be the middle point? 0. So the average will also be 0, and also the median will also be the at the 0. Clear? For the symmetric distribution, you can clearly see mean and median are coinciding with each other. Okay. But now what I will do is, in the above plot, the mean and median are both so close to 0 that the red line is on the top of a thick black line. Okay, red line is at the top of the thick black line. Because if you see, the line width of black line is 5, okay, and line width of red line is 2. Okay, that's why we wanted it to long little fat black line. Okay, as you can see the black, the in skewed, this is what the symmetric distribution, right? But if in symmetric distribution, what happens over here is the mean tends to get pulled in the direction of skew. Okay, just like this. In skewness, the mean tends to get in the direction of skew. Okay, here what is the skew direction? This direction, let's say positive direction. The mean gets pulled away. Here negative direction, the mean gets pulled away. Okay, theoretically. But here if you see, if you see, if I want to show you, see here what I'm trying to say, I'm trying to take another distribution called as exponential distribution. Okay, earlier if you observe, we took np dot random, sorry, random dot normal. Here we are taking np dot random dot exponential. And what is exponential, guys? If you see exponential distribution, so exponential, it will increase, right? Exponential rise, they say e to the power of minus e to the power of x, I think. Okay, there will be exponential rise. If it is a normal rise, then it will be something like this. But if it is an exponential rise, okay, it will suddenly increase. Okay, exponential rise. Okay, now if you see, and but obviously that is not going to the normal. So here what I'm trying to do, so if you see pd dot data frame, and I'm creating an exponential data called as skewed data, fine, and I'm plotting the same thing, fine, and vertical lines, okay, exactly the same thing. Now if I see the distribution, as you can see, what's the red line, guys? Red line is the median, right? Black line is the mean. Agree? So and now what is this distribution? It is a skewed distribution. Agree? You can say it is a skewed distribution. You can say this is an asymmetric distribution. Agree? And what type of skewness? This is a positive skew. Correct, Siri. It's a positive skew distribution. And now, as you can see, in positive skew distribution, mean will be pulled into that direction. As you can see, there is shift of median also. Okay, there is shift of median also, but that will be a small shift. But when compared to, I would say the median, the mean gets shifted much. Okay, earlier they were both are over here. Okay, from here the mean gets shifted over here. Okay, but if you take more numbers, or if I say instead of 1 lakh, if you take 10 lakh numbers, okay, this exponential curve will be more exponential. Okay, it could be something like this. Okay, in that case, the mean will furthermore shift. The median might shift a slight shift, but mean will drastically shift. Okay, the shift of mean will be always greater. Okay, so that's why, as you can clearly see, the shifting of the mean, okay, due to the skewness. If it is to the left side, then that is called like negative skewness, and the mean will get shifted to that direction. Okay, so this, by this you can practically observe, okay, whatever we have made a statement over here, what statement we have done, and from yesterday what we are discussing. Okay, you can see the theory over here, and you can also see the practical example over here. Agree? Fine. So as you can see, the mean is also heavily influenced by outliers, while the median try to resist the influence of outliers. Okay. So yeah. So regarding the outliers, fine. So if I try to wantedly create an outliers, we will see. Okay, this is just an asymmetric distribution, guys. Okay, skewed distribution. Okay, what we have seen, the exponential asymmetric distribution. Now, if we try to add some outliers. Okay, deliberately we are trying to add some outliers. Okay, see how we are adding. We are creating two types of distributions. One is np.random.normal. Okay, and then we are doing np.random.normal, but with some other uh, number. Okay, the value which we are seeing over here is 15. Whatever you are seeing over here, right? So that will be the, if you want to specifically mention what should be the mean of the given distribution, you can give it over here. Okay, if you don't give anything, it will usually take the value. It will usually take let's say, yeah, like if it is minus 7.5 plus 7.5, okay, the mean will be 0. Okay, if you don't mention anything, as it will take it as 0, guys. Okay, so for example, if you see over here, so in the normal distribution, we did not mention anything. We just said, hey, create a normal distribution. It will create with all the given points, whatever given points it will consider, and it will create, and it will put the mean at the 0. Okay, it will put the mean at the 0. Okay, but now here if you want to deliberately say, see, for this distribution, whatever you're having this distribution, right, norm data, that is this data, that is this big line, big blue line. Okay, this only till here, till here. Okay, till here. For that, what is the mean? As you can see, sorry, what is yeah, what is the mean or median? 0. Fine. But to this, what we are doing, one more distribution we are creating called as np dot, what is data frame? Is this data structure? Data frame is simply a table, Sirisha. It is just a table. So if you are having this Excel sheet, if you convert this here, you are calling it as Excel. Okay, but if you convert it into pandas, it is called data frame. That's it, a table, simple table. We will see that in pandas. Okay, but yeah, but the point here is np.random, one data frame we have created. Okay, one but the second type of data is, we are saying, hey, I want the mean should be 15. Okay, use 3 points. This is size is just how many points you want to use, this 51. But the here, if whatever what we mentioning over here in the first parameter is what, this is 15. That means I'm saying, hey, I don't want 0 as mean, I want 15 as the mean. Here I'm not specifying anything, that's why it will take 0 as the mean, and it will create some data frame, some distribution. But here I'm saying 15 should be my mean. So as you can see, come here, if you see here, for this it is almost at the 15. The mean is at the 15 for this small distribution. Okay, this is initially, this is a distribution, guys, first distribution, and there is one more distribution, this small distribution, as you can see, where the mean is around 15. Okay, and this is second distribution. Okay, now if you separately, these two might be perfect distribution. Separately, if you see, this might be a normal distribution, and this might be also a normal distribution. Agree, this also looks like a bell curve almost. This might be a symmetric distribution, if not normal, at least this might be a symmetric distribution, and this also might be a symmetric distribution. Agree, both are symmetric. But what we are doing, we are concatenating both of things. Okay, see, np.concatenate. Okay, so you are creating a data frame. By concatenate means what, adding. Okay, putting together both the distributions. How? See, np.concatenate, to this function we are passing the normal distribution data, and this new small distribution, which is we are calling it outlier distribution. When we concatenate these two and create new data frame, that will create this combined data. And when we plot the combined data, as you can see here, it is creating this distribution. Now if you consider the whole distribution, this is not normal anymore, or this is not symmetric anymore. Agree, you have wantedly created some outliers and added to here. And now if you consider the whole distribution from here to here, this is not a normal distribution, right? Even if you divide it into any place, even if you cut it here, the left side is never going to equal to the right side. Okay, so obviously this is asymmetric distribution. Agree, this is a skewed distribution. Agree. Now, for this type of data, if you try to calculate, as you can see the plot, we are plotting the mean and we are plotting the median. Okay, so now you can clearly see the mean is getting shifted. The mean is getting shifted towards this direction. Okay, but if you add some negative values similarly over here, that means if you add over here, the mean will get shifted this direction. Clear? For outliers also, you can clearly see a shift. Okay, see, as you can see, since the median tends to resist the effect of skewness and outlier, it is known as robust statistic. Okay, median, it will tend to resist the effect of skewness and outlier. So even though you are here, what is this? This is an outlier. Okay, this is an outlier. Fine. In the above case, what are these? This is a skew distribution. Okay, this is some skew distribution. Can you see the skewness over here? Can you try to relate this distribution, skew distribution? Okay, so in this position, skew or the outlier. So this is completely unwanted new data. Okay, so this is outlier in both of this, either skewness or outlier. The median will try to more or less stay over there only. Okay, that's why it's called robust, very strong statistic. Okay, the median, that's why the median generally gives a better sense of typical value of a distribution with significant skews or outlier. That means if you have significant, that means if you have a considerable, okay, few degree of skewness or certain amount of outliers, still the median will generally give a better sense of value of the distribution for a significant. But if the skewness is extremely skewness, guys, okay, if you are intentionally creating very skewed distribution, in that case median might also have a good shift. Okay, and if you're adding unnecessarily a very, it's very asymmetric, that means the outlet, the range of outliers is very high. In that case, mean will anyhow shift, but median will also lose its patience and it will also shift a bit. Okay, but more or less when we are having significant, that means considerable amount of skewness and outliers, median will mostly resist the effect. Okay, but as you can see, the mode of the variable is simply the value. Okay, that is median and mean, right? But now coming to the mode. Okay, mode, what was the mode? Yesterday we have seen the one which is repeating more frequently. Agree? So the mode of the variable is simply the value that appears most frequently. Unlike mean and median, you can take the mode of a categorical value. Okay, and it is possible to have multiple modes. Okay, you can take mode is just the maximum number of value that is repeating. Okay, it is not related to, oh, sorry, it is not disturbed like mean or median. Okay, just the maximum number of value that is repeating, that will be the mode. For example, if you see here, yeah, how you can get the mode? Empty cars dot mode will give you the mode. Okay, so here if you just go over here and if you do just mode, that means in mpg, okay, this one is the most repeating. Okay, this one is the most repeating. For example, that why? Because if I just show you, yeah, so if I go over here, right, and if I put it over here, okay, so here for this mpg, okay, the mode is 13. Okay, because 13 is the most repeating value in this mpg. Okay, why? How do I know? Because there is one function in pandas, okay, which is called value counts. That means if you give this mpg over here, and if you say data frame, inside that I want the column which I want, and inside that if you say value counts, okay, it will give you how many times each value is repeating. Okay, 18 is repeating how many times, 15 is repeating how many times. Okay, that is the function value counts. Okay, we will see when we are studying pandas. Okay, but now just I will show you. Okay, as you can see here, oh, sorry, as you can see here, 13, okay, 13 is repeating the most number of times, 20 times it is repeating. 14 next 19 times, 18 17 times. Okay, these are the numbers, actual numbers which are present in our data frame, and the corresponding number of times they are repeating. Clear, guys? Okay, see, if you see 13 20, right? So if you want, if I just want to show here, go to mpg, take a filter, put a filter, go here, just remember 13. Okay, see how many times it is repeating. Can you see the count? 20 over here, 20 over here, right? Fine. So this will be the highest. Okay, these are the values you are getting over there. Okay, so that means every value how many times it is repeating. So as you can see, and that is the mode, right? What is mode, guys? What is mode? Mode is most frequently occurring value, right? Most frequently occurring value, the value which repeats maximum number of times. That's it. Fine. So 13, as you can see, the maximum number of 20 times it is repeating, and every number is less than 20. So that's why the mode of the mpg column, okay, this might be mileage or something. Okay, so that is what? That is 13. Okay, mpg. And now for cylinders, if you see, if I take cylinders, okay, and if I see, what is this? Number 4. Okay, as you can see, there are different numbers for 8 something, all numbers. For 8 is repeating just 1 or 3 times, but 4 there is some number. This here we are not seeing the whole data frame, it will show only 5. Okay, but if you see, but if you just filter it out, and as you can see the cylinder is having some 4 value also. That 4 is repeating how many times? Okay, that 4 is repeating 204 times. Okay, that's why the mode is empty dot cost mode. The mode is 4. Okay, like that for each and every for each and every column. Is this clear, guys? The mode, are you able to understand the mode part?
Yes, sir.
Okay, but did you get the doubt why there are two modes? Sorry, two rows. Can anybody just give a guess why you are seeing two rows over here? Any guess?
Maybe it have more than one mode.
Which one?
The weight.
Perfect. Good. So that's why if you see the if I show you displacement, okay, displacement, if I see displacement is 97. 97 is the for displacement, 97 is the mode. That's because it is repeating 21 times. Okay, as you can see, displacement 97 is the mode. Okay, but and also if I show you horsepower, 150 is the mode because it is repeating maximum 22 times. Okay, as you can see 150. Fine. But if you see the weight, see 1985 is also repeating 4 times, 2130 is also repeating 4 times. Agree? So that's why 1985 and 2130. There are two modes. Okay. And that's why yesterday we are clearly seeing for the mode, it can a given column can have 0 mode. That means if no one is repeating, then there is no mode. It can have one mode like this, all other columns having one mode, or it can have multiple modes. Okay, here you are having two modes. That means both of them are repeating equal number of times. Then we will consider two modes. Okay. And acceleration, only one repeating model only once, origin only once, car, food also only once. Okay, for categorical also you can take, guys. See, these are all, what are these are all numerical values. Fine, yesterday we have seen. But car name, what is this car name? This is not a numeric, this is a categorical value. Even for car name also you can take the mode. Okay, so if you see Ford Pinto, that car is repeating 6 number of times. Okay, that's why it is having Ford Pinto as a car name. Okay, so I would say that's all I would like to cover today. Okay, but I hope you understood the concepts, like new concepts, important concepts. Okay, try to give it a reading. Okay, so this is a foundation. It will be for your future classes. Okay, symmetric distribution, asymmetric distribution, skewness, right? Normal distribution, fine, and mean, median, mode, practical, and also how you can find out on the given data frame. Fine, and the effect of, we have clearly seen the effect of mean on how many. We have seen it on symmetric distribution, no effect. On exponential or asymmetric distribution, we have seen what is the effect, and also on the outliers we have seen the effect. Okay, the mean, median. And coming to mode, it is just the most frequency. As you can see, it will have 0 mode or 1 mode or multiple modes. Okay, so yeah, so that would be the today's class. Okay, tomorrow, yeah, so tomorrow we are going to have a good extension, and I will try to show you a few more examples. And then we are going to study tomorrow very important concepts called as standard deviation, okay, and variance. Okay, these two are the fundamental concepts to study about all further distributions. And as I said, normal distribution, which we have just studied today, okay, the whole statistics what we are going to study is dependent on this single distribution. Okay, for this to understand, you should understand standard deviation and variance. Okay, fine, so that will be for tomorrow. But I hope today you got the concepts right. Any doubts, guys, or are we good? Any doubts, or did you follow the concepts really?
Yes, sir. Follow.
Okay, perfect. Okay, that's all from my end. Fine, thank you so much for joining. Tomorrow let's continue.